This lesson is all about understanding the basics of how a unit circle works or how to read a unit circle. So we're going to kind of ignore a lot of the coordinates going on and just really focus in on what these degrees mean, and then that sine is the y coordinate x and cosine is the x coordinate, and why that is so. So let's first start with the degrees, and then we'll go over the whole x and y coordinate idea. So when you read a unit circle, you know, it's probably better if I draw the circle first. And that worked a lot better. So when reading the unit circle, this is a coordinate plane. So it falls on a coordinate plane, this being the x-axis and the y-axis. And so what you have is you have points that lie on this circle, which are the same distance from the origin, you know, whatever this length is. And it's called the unit circle because this length is always 1 on the unit circle. So any given point on this is going to be 1 total unit away from the origin. You can kind of picture if you had a string, same length string, and you, it's probably better if I just, messed that one up, right? But let's just say you had the same length string and you pin it down to the origin right here, and you put your pencil and you just draw, and that string's attached to your pencil, so it's the same length all the way around. That's what's going on. So that length is always 1. That's how a circle works. There we go, got that perfectly. Okay, so how do we measure the angle? Well, depending upon where we're at, let's just say we're right here, it's the measure of this angle here. That's always the angle. So our starting side is always this side right here. That's going to be our starting side. So we start at this point here. That's where we start. And then we go counterclockwise. So starting from that spot, we move counterclockwise. So what's the angle that's created there? So right here would be your perfect 90-degree angle. Once you go beyond that spot, now we're over 90 degrees. And then what's a line? A line is 180 degrees. So once we're there, once we're halfway across the circle, that's 180 degrees. You continue doing that, that's now 190, 200, 210, so on. This is actually 270 right at this point. Think about that. That's actually really important. This type of process is what you got to know in this assignment, actually. So this is 180 degrees for half the circle. So an additional quarter of the circle, remember, a quarter of the circle is 90 degrees, right? So if a quarter of the circle is 90 degrees, half the circle is 180 because it forms a line, right? That angle formed starting here, that angle formed is 180 degrees because it's a perfect line now. And then you continue 90 degrees, 90 plus the 180 is going to get you to 270. Add another 90, 360 degrees is an entire circle, right? So 180 is half the circle, another 180 bring you around to the entire circle. So this should all kind of make sense if it doesn't, think about it. So if we see an angle right here, the angle that we're looking at is actually the entire angle formed from right here to this starting side there. And like this angle here would be the angle formed all the way around that circle. That's why we're going beyond 180 degrees now. So how does that have to do with anything? Well, right here, this says, what is the value of the x coordinate? Well, how many degrees is this? We know that there's 20 degrees taken up there, but there's 90 degrees taken up here. So our angle, our total angle is 110 degrees. So that's why this is important. Right here is 15 degrees away from the spot, but remember we want this angle here. So the whole thing's 180, take away 15 would be 165. So that's how the angle works. 310 degrees, well, this is our start. This is our 0 degrees. We go around, that's 90, 180, 270. So 310 degrees is probably right here, right before we get all the way around the circle to 360. So it is important to know how to read this. 200 degrees is a little bit more than 180. Remember, right here at this spot is 180. So a little more than that would be 200 degrees. So kind of some key angles there. Remember, this would be 90 degrees, this would be 180 degrees, this is 270 degrees, and then change my 2. And this is 0 degrees or 360. So now let's talk about which one's the x and which one's the y coordinate. Well, if we form an angle on this side here, let's just form an angle. I should pick a different one. So that this angle that's formed here, why wouldn't I just use a perfect line, right? There you go. So that angle formed here, we're going to call that theta. That'll be like our reference angle, right? And actually what that's going to do is that's going to create a triangle. And this point is kind of our key point. We're going to be focusing, the points on the circle. That's actually what we're looking at. So it's based upon the angle. We're going to reference, it's always a reference angle, right? We're going to refer to the angle. That's why those degrees that we were looking at earlier made a difference. But this is a coordinate on the coordinate plane. This is a point on the coordinate plane. So there's an x coordinate and there is a y coordinate. So that's really key here. Remember, this is the x-axis, y-axis, which is interesting because over here our x values, wouldn't they be negative? And down here our y values would be negative. So you pay attention to those little details. They are important. So anyways, if you look at this, the opposite, actually let's start with the adjacent. This would be the adjacent side. Notice that is whatever our x value is. That's on the x-axis. So our adjacent side is going to be the x coordinate. But remember, cosine is technically adjacent over hypotenuse. Just in our case, the hypotenuse, isn't that the radius? Multiply the r over. And the adjacent side, isn't that really just the x coordinate? Let's do this. And so that, if you solve for x, you just multiply the h over. Oh wait, I meant to say that's r, right? That's the radius. Adjacent over hypotenuse. We'll keep it kind of the classic adjacent hypotenuse, just like we did with our right triangle trig. But if you think about that, in terms of this circle and this coordinate plane, the adjacent side is the x coordinate, and your hypotenuse is the radius of the circle. Think about that. It's important. So x, if you solve for x, you multiply the r over, is r cosine of theta. Now remember we said it was the unit circle. Means that r is 1, our radius is 1. So the x coordinate is cosine. Let's go ahead and go over the y coordinate now. So the y coordinate is going to have to do with the opposite. Here's our opposite side over the hypotenuse. Now realize the opposite is the y value. The distance, that vertical distance, is whatever our y value is. Just a particular y value that we have. That's why I put y0. So sine, if you remember, sine of theta from SOHCAHTOA is opposite over hypotenuse. I just realized I kept that as r. I keep getting these mixed up. So I'm trying to take it back to SOHCAHTOA, basically. Try to derive this from SOHCAHTOA. So opposite, in this case, is the y value over the hypotenuse we said was the radius. So in general, y is equal to r sine of theta. But remember, since we have the unit circle, in the unit circle, r is 1. So the x coordinate is cosine, the y coordinate is sine. And that's the reason why. So if we look over here, they want to know what's the value of the x coordinate. So that's going to be cosine of this angle. So cosine of 110. Over here, the y coordinate would be sine of this angle, 165. Remember, we want to use the angle created from this side here, the right side there of the the right half of the x axis. I think it's called the terminal side or something like that. I have to look it up. Should have looked it up before I did this video. Which coordinates is equal to sine of 310? Remember we said sine of 310 is probably going to be the angle right here formed. Wow, that was really horribly drawn. That's going to be 310 degrees. Sine's going to be the y-coordinate. So y-coordinate of point C. And I didn't put that. I'm sure there was part F here. I'm pretty sure there was. I think I cut it off. And then sine of 200. 200 is probably right here at B. So that's going to be the sine is y-coordinate of point B. And that's how you read a unit circle. If you ever want like sine of 150, you look for the degrees and you look at the y-coordinate. If you want cosine of 45, you look at for 45, the degree 45, and look at the x-coordinate. And that's how it's going to work, and that's what we're going to be doing in future assignments.